this is Devi, and in this video I'm going to be explaining about the logic behind implementation of sum of two polynomials which are stored in a single array. So in the previous video we saw the representation of two polynomials in an array. In this we are going to see how addition is actually applied and how it is stored into this array. So we'll see the logic behind it. Firstly, from each term a and b, from each polynomial a and b, one term is selected. So if you look at these two terms, they are not of same exponent, right? So we are going to take the largest exponent and put it to your sum. So let us say I'm going to call the sum as d of x or d polynomial. Now the largest exponent is going to be put to your polynomial d. So 5x power 6 is going to be stored as your sum first term. Now look at the next term. So we are done with 5x power 6. Take the next term in the a polynomial. We are still not done with the 3x cube in b. So we are going to leave it. We are going to still take that into consideration. Now look at these two terms. Both of them have the same exponent 3, right? So we have to add these terms. So when you are adding these terms, you see that the coefficients are 3 and minus 3. When they are added, they become 0. So those two don't get actually added to your sum. Next we are going to move on to the next two terms. If you look at these two terms, so we are done with these. Let's strike it out. Now we have 7x square and 2x. Whichever has the largest exponent, that you are going to add it to your sum. So 7x square is the largest exponent, so that you are going to add it to your sum. So you get a 7x square as the next term in your sum. Now you are done with 7x square. Moving on to the next term in b, that is 5x. So you have 5x and 2x. Both of them have the same degree, that is your same exponent. So we are going to add those two. So you have 2x and 5x. So when added, it becomes 7x. Now 7x is going to be added to the sum. Now you have reached the end of your polynomial a, but there are still terms in polynomial b. So even though you reach the end of any one of the polynomials, you have to make sure that whatever is left in the second polynomial or the first polynomial, that gets added to your sum. So the term plus 9 should be added to your sum. So plus 9 is going to be added, and you're going to get the answer as 5x power 6, 7x square plus 7x plus 9 as your sum for the polynomial ax and bx. Now how do you actually implement it in code? That we are going to see in detail in the next video. So we are going to first explain it here. So you're not going to actually see the whole terms. So when you are applying it in logic, so you are going to have an array here. So using this array, you are going to actually add the terms, applying the logic which I explained here, and the sum is also going to be stored in the same polynomial. So in order to indicate the availability spaces, that is avail, you are going to use a word avail to indicate that is the available place for you. So from where you are going to store your answer. Now how do I add? As same logic, we are going to take one term from SA and one term from SB. You are going to check the exponent here. You are going to compare the exponents. You will get 6 and 3. So you are going to take whatever is the largest, put it to your avail list. When you have equal exponents like 3 and 3 which we had, you are going to add them on addition. If the answer is not 0, you are going to add the sum to your avail list. Similarly, once you are done or once you reach the end of any one of the polynomials, you have to make sure that you take the remaining ones and add it to the avail list. So that is how you are going to follow. That is the code you are going to write in order to add two polynomials using arrays. The code is going to be explained in the next video. I hope you have understood the logic behind the sum of two polynomials using arrays. Have a good day. Thank you.